right, we're looking at lesson 6 in unit 2. And so the first question says the regular polygon below is rotated about its center. Which angle of rotation will carry the figure onto itself? So first of all, this is a pentagon, meaning it has 5 sides. And so if you want, you can kind of sketch this out as the center here, and then picture each rotation. There would be 5 equal rotations since there's 5 sides here. So to figure out how many degrees each rotation would be, you would take 360 and divide by 5, which would give you 72 degrees. So if I wanted to rotate this point to this point, that would be 72 degrees. Now, if you look at your answer choices over here, 72 is not an option. So you have to keep rotating. If I rotate the next one, 72 plus 72, another 72, 72 plus 72 would be 144. That's not an option. So you're going to keep going. Picture rotating this all the way to here, add another 72. Basically, what you're looking for is which one of these is a multiple of 72. So it could be more than 360, but you're going to add 72s until you get to one of these answers. I'm not going to tell you the answer. I'm going to have you keep going there. Whoops, back to this one. So let's go ahead and look at a couple more of these. We're not going to do them all, but I'll take a look at question number 2. Question number 2 says, which rotation about its center will carry a regular decagon onto itself? Well, you need to know that a decagon has 10 equal sides if it's a regular decagon. So you're going to do 360 divided by 10, and you're going to get 36. So in this case, you're looking for which one of these is a multiple of 36. Okay, that's an F there. Again, I'm not going to do it for you. I'm going to have you try that on your own. Number 3, which figure has exactly 4 lines of reflection that map the figure onto itself? Lines of reflection can also be thought of as lines of symmetry. So here you're looking for symmetry. And so these were the 2 that were a little bit more difficult, number 4 and 5. Number 4 says which transformation would not carry a square onto itself. So let's just start out by sketching a square. If there's not a diagram given, you should always draw one. So a reflection over one of its diagonals. That means if I reflect this way across a diagonal, will this half lie on top of this half? And yes, I believe it would. If I rotate around its center 90 degrees, so that's here to here, this would actually be 90 degrees because 360 divided by 4, there's 4 equal sides, is 90. So that should be good. A rotation of 180 degrees around one of its vertices. So let's think about what that means. If I pick a point here and I rotate 180 degrees, so I'm going to picture taking this side and I'm going to rotate it so that it comes over here 180 degrees, which means this side would flip down here. This side would end up way down here. And so in this case, does the square lie on top of itself? No, it doesn't. So it's going to be that one. The last one was a reflection over the perpendicular bisector of one side. Perpendicular bisector of one side would look like this. And if I reflect over that line, then this side falls on top of that side. So that one's good. Last one, number 5. A rhombus is graphed on the set of axes below. Which transformation would carry the rhombus onto itself? Choice 1, a rotation of 180 degrees around the origin. The origin is here. If I rotate 180 degrees, this point is going to lie down here. So that is not going to work. We're looking for the one that does work. A reflection over the line y equals 1/2 x plus 1. Remember, this is my slope and this is my y-intercept. If I sketch that line, I'm starting at 1, I'm going up 1 over 2. Or from here down 1 over 2. if I reflect across this line, is this point going to lie on top of that point? And my answer is going to be no. That is not going to work. A reflection over y equals 0. Y equals 0 would be right here. If I reflect over that, does this half lie on top of that half? Yes, it does. Okay, so that one's choice 3. This one, x equals 0, would be here, and that would not be a line of symmetry. Right, that's it for that one.